9th standard students, in this video I am going to continue the lesson motion. In the previous video we learnt about motion. Motion is the action of changing location. Motion is described in terms like distance, displacement, speed and time. Rest and motion are relative terms. Then we learnt about types of motion: uniform motion, non-uniform motion. What are uniform and non-uniform motion? If an object covers equal distance in equal intervals of time, it is said to be uniform motion. If an object covers unequal distance in equal intervals of time, it is said to be non-uniform motion. Distance is the total length of a path taken by an object. Displacement is the shortest distance from the initial to the final position of an object. Then we learnt about speed, velocity, acceleration. Speed is the rate of change of position. Velocity is the rate of change of displacement. Acceleration is the rate of change of the velocity. Now we are going to see about graphical representation of motion. What is graph? A graph is a pictorial representation. This graph shows relation between two sets of a data, of which one set is of dependent variable and the other set is of independent variable. To describe the motion of an object, we can use line graphs. In this line graphs, dependence of one physical quantity such as distance or velocity on another quantity such as time. Distance time graphs. The change in the position of an object with the time can be represented on the distance time graph. In this graph, time is taken along the x-axis and distance is taken along the y-axis. Distance time graphs of a moving body can be used to calculate the speed of the body as they specifically represent velocity. The distance time graph for a body moving at uniform speed is always a straight line, as distance travelled by the body is directly proportional to time. In this graph, you can see that there are three bodies A, B and C. All of them are in uniform motion. Then, why do they have different slopes? It is because the slope of a distance time graph determines the speed of that body. So, steeper the slope, steeper means larger values. So, the steeper the slope, greater will be the speed of the body. From this graph, we can come to a conclusion that body A has the highest speed and body C has the least speed. The slope of the line on the distance time graph becomes steeper and steeper as the speed increases. The distance time graph for a body moving with non-uniform speed is a curve. Next, velocity time graphs. The variation in velocity with the time for an object moving in a straight line can be represented by a velocity time graph. In this velocity time graph, time is represented along the x-axis and the velocity is represented along the y-axis. The product of velocity and time gives displacement of an object moving with uniform velocity. The area enclosed by velocity time graph and the time axis will be equal to the magnitude of the displacement. Now, velocity time graph of an object moving with uniform velocity. The slope of a velocity time graph of an object moving in rectilinear motion with uniform velocity is straight line and parallel to x-axis. When velocity is taken along y-axis and time is taken along x-axis. A flat horizontal line in this velocity time graph states that the body is moving at a constant velocity. Now, let us calculate the distance using velocity time graph. Let 2 points A and B on the slope of graph. Draw two lines parallel to y-axis. One line AC from point A and another line BD from point B. Let point D at the x-axis is T2 and point C is T1. Let AB meet at B at y-axis. That is, object is moving with a velocity b. Thus, distance or displacement by the object is equal to the area of the rectangle. The shaded area is ABCD. Thus, area of ABCD is equal to BD into DC. So, S is equal to B T2 minus T1. Since given object is moving with a constant velocity along a straight line, thus displacement will be equal to distance covered. Therefore, distance or displacement is equal to velocity and into time interval. Next, velocity time graph of an object moving with uniform acceleration. When velocity time graph is plotted for an object moving with uniform acceleration, the slope of the graph is a straight line. The pattern of slope of the graph shows that object is moving with uniform acceleration. Calculation of the displacement and distance covered by the moving object using velocity time graph. Let take 2 points A and B at the slope of the graph. Draw a line from B to BD and another from point A to AE parallel to y-axis. Let AD meets at T2 and AE at T1 on the time axis. Thus, distance covered by the object in the given time interval T2 minus T1 is given by the area of ABCDE. Therefore, distance is equal to area of triangle ABC plus area of rectangle ACDE. So, S is equal to half into BC into AC plus AE into ED. Displacement of the object during the given time interval t2 minus t1 is equal to area of ACDE. So displacement is equal to AE into ED. Now, velocity time graph of an object moving with uniform decreasing velocity. The slope of the velocity time graph of an object moving with uniform decreasing velocity with uniform acceleration is a downward straight line. The straight downward slope shows the decreasing velocity with uniform acceleration, that is uniform retardation. Next, velocity time graph of an object moving with non-uniform velocity. So zigzag line of slope of this graph shows that the object is moving with non-uniform velocity. Students, next video we will see about equations of motions.